Alright, welcome students to Exponents Part II, where we will conclude our discussion of exponent rules. So let's go ahead and get started. Now if you remember, just real quick to recap from the last screencast, given some base, say 6, raised to some exponent or power, say 3, well that really just means 6 times 6 times 6, which once you do the math would equal 216. And we called this the exponent form, and we called this result, once we've evaluated that expression, the standard form. And also in the last video we talked about, say for instance you have 6 to the negative third power, or to the negative 3 power. Well, that just means 1 over 6 to the positive 3 power, which would then give us as a result 1 over 216. So that's a recap from the last screencast. Now let's talk about some new material. Well, one of our exponent rules is called the product of powers. And all this means is, say if we have the same bases and we multiply them together, say a to the n, or a to the m, times a to the n power, well, that just means take that base a and raise it to the m plus n power. So, for example, if I have 7 to the third power times 7 to the fourth power, well, that just gives me 7 to the third plus fourth power, or better written, 7 to the 3 plus 4 is 7 power. So in a nutshell, that's called the product of powers rule. Now we also have the quotient of powers. For instance, quotient of powers. Say we have a to the m divided by a to the n. Well, instead of adding those powers, since we have the same base, we can just subtract them. A to the m minus n power. For instance, say again we have, let's use the example we had last time, 7 to the fourth over 7 to the third. Well, that's just 7 to the fourth minus third power, which is really just 7 to the first, or better written, 7. So in a nutshell, that's called the quotient of powers. Now our next rule will be the power of a power. And often that will be written as a to the m using parentheses to the n power. Well, when you raise some base with an exponent to some power, you multiply the exponents. So a to the m times n power. So let's go back to the running example that we have. Say we have 7 to the fourth power, quantity raised to the third power. Well, that's 7 to the 4 times 3 power, or 7 to the 12th power, where 7 is our base and 12 is our exponent. So that's our power of a power rule. Now let's look at another example. And this is a special case that you're going to need to just place into your memory banks. Power raised to 0, or power of 0. And all this means is anything raised to the 0 power equals 1. So for instance, say I have 7 raised to the 0 power. That means my result is 1. What if I have 100 raised to the 0 power? Well, that's still 1. What if I have 1 raised to the 0 power? Well, that's 1 as well. What if I have 1/4 raised to the 0 power? Well, that's still 1. Okay? Just like 0 multiplied by any number is 0, any number, any base raised to some power, well, that's going to be 1. Let's quickly look at two more. Power of a product. So for instance, say I have some base written as a times b raised to some power. Well, that's the same thing as a to the m times b to the m. So for instance, say a is equal to 2 and b is equal to 3. Well, 2 times 3 to the m power is really the same thing as 2 to the m power times 3 to the m power. Or if we want to write it as 2 times 3 to the second power, well, that's going to be the same thing as 2 to the second power times 3 to the second power. And then we could evaluate that and come out with an answer in standard form, which I'm not going to do right now. Our last one is power of a quotient. For instance, if I have some a divided by b raised to some power, and remember, b cannot be 0, well, that's the same thing as a to the m divided by b to the m, provided b does not equal 0. So for instance, say I have 2 divided by 3 raised to some power. We could say the m power, or maybe we say the second power here. Well, that's 2 to the second power divided by 3 to the second power. And that's our power of a quotient rule. We'll be using these rules in class to solve problems, especially applied problems. So my suggestion to you is to make sure you have these examples in your notes and ready to go tomorrow for class. Thank you, and that'll conclude this screencast.